Good afternoon. In this video, we are going to talk about proposition 4 from book 1. Before the start, I would like to say the proof of proposition 4 is probably one of the most controversial proofs in the elements, and we'll talk about it later, okay? So let's start the proposition. This proposition declares that given two triangles with equal sides, two equal sides, and an equal angle contained by these two sides, then the third side are equal, and the remaining two angles are equal, and the triangle themselves are equal. Okay? So in this example, we are given conditions like AB equals to D and AC equals to DF, two sides, and the contained angle here, angle CAB is equals to angle FDE. And let's prove it. So in Euclid's book, we will have to use a method called superposition. So at first we move point A to point D, okay? And then we move the edge AC here, as well as AB here. And since we have AB is equal to DE, we can conclude that point B and point E are coinciding. And similarly, we know that point C and point F are coinciding because these two sides are equal, okay? Then we know that BC and EF are coinciding. And because of common notion 4, two coinciding objects are equal. So we know that BC is equal to EF. So this proves that the third angle are equal. And then we can say that the triangle ABC and triangle DEF, after the movement, okay, they are coinciding, so they are equal. So we prove that this triangle ABC equals to triangle DEF. And similarly, we know that this angle and this angle are coinciding, so they are equal, and the remaining angles are also equal because they are coinciding. This ends the proof. This ends the proof. It is short but really controversial because of the superposition. Let's talk a little bit about the superposition, okay? So nowadays in modern mathematics, people are arguing about the way to prove this proposition because there are two arguable points. Okay, so the first of all, Euclid said we will need to move the point A to point D, or we will move this triangle on this triangle, or let's say this triangle will be superposed on this triangle. But the problem is that superposition or the superpose, how are we going to superpose it? This definition has never been declared, or Euclid has not defined what is a move or what is superpose. For example, it can contain two kinds of operations, that is translate and rotate. But all of these concepts have not been defined in the elements. So this is pretty arguable. And the second arguable point is that what is coincide? Because Euclid has at first used this terminology or concept in common notion 4. He declares that two coinciding objects are equal. But what is coincide? It had never been defined. So people might think this is not strict. So the superposition proof method is still arguable and controversial. And in order to solve it in modern mathematics system, there are probably two methods. So the first is that people can treat this proposition, so this is a proposition, treat it as a postulate, or let's say axiom. So it becomes from a proposition that needs to be proved to an axiom which is self-evident, which is always true. It became a truth. So this became a truth. And the second method is that some people have developed a more complicated and complete axiom system, which enrich Euclid's 5 common notions and 5 postulates. This system has been enriched, and in the developed system, we can give this proposition a pretty strict deductive reasoning proof. And if you are interested, just refer to some topics about them. And at the end of this video, I would like to briefly introduce another concept which is called congruence. So in this proposition, actually these two triangles are congruent. So the congruence means, in geometry, congruence means two figures have the same shape and the same size. So in this problem, we can see that these two triangles, they have the same shape, and in terms of size, they have the same size and the same angles. Okay, so we can say this triangle ABC is congruent to triangle DEF. Okay, I think that's a brief introduction, and we have completed this video, and in the next one we are going to talk about proposition 5. Thanks for watching. Have a good day.